Alright guys, welcome to Algebra 1. Hey, first thing I want to say is tell your parents to vote tomorrow on the school budget. Go to the Browns River Middle School or Camel's Hump or wherever it is in the other side of town and vote. As of right now, there are a number of teachers who do not have contracts for next year. I'm one of them, which means I won't have a job next year if we can't get the budget to pass. And I'm also a community member. I live in Underhill, and I'm definitely voting yes for the budget because I want to support you guys as students as well. For example, you're using a laptop right now that's owned and paid for by the school so that you can use it independently. So my tax dollars are paying for that, and I'm voting yes to keep paying for that. So you guys have great technology to use that. So quick little plug there. Please encourage your parents to vote, and please vote yes. But obviously voting either way is important part of a democracy. So back to math. Sorry about that, guys. The first thing we're going to dive into here is solving equations, and they're going to involve radicals. So on your paper, this first one, you already know how to solve problems like this. This is from the last chapter, actually. I'm going to go through this kind of quickly because I'm actually in a rush to move on to something else in my own life here. I want to get home. But first equation here, subtract 14 from both sides. That's pretty easy. You get 6m squared equals 24. And then, of course, you guys know you divide both sides by 6. You get m squared equals 4. And then, of course, you go, how do I solve that? Well, you can either bring the 4 back over and factor it, which I would not recommend doing, or you can take the square root of both sides. And, of course, the square root of 4 is 2, but you also remember this is a quadratic, so there's 2 answers. Negative 2 would also be a valid solution. If you plug negative 2 back in, you'd square it, you get 4. 4 times 6 is 24. 24 plus 14 gets you back to 38, so it would work. The second problem is a little tougher, and of course my stupid PowerPoint here doesn't have my square roots on it. So I'm missing the square root of 3x plus 1, which is on your paper, so ignore, I'm missing the radical here. So the idea with the radical equation, you've never solved something like this. It's actually pretty easy, relatively easy. Not easy, but relatively simple. It looks more complicated than it is. So I want to get this square root by itself. So I want to move the 6 over. And I'd often, if I was in class, I'd say, how do you move the 6 over? We'd say I'd add it to both sides. And you'd get something like that. 3x plus 1 equals 10. The problem on the right is the exact opposite, or in math we call this an inverse, of the problem on the left in terms of what you do to solve at this step. Here we had a squared, so we took the square root of both sides. Here we have a square root. The opposite of a square root is squaring both sides. So if I square this side of the equation, I would just get 3x plus 1. In other words, a square root squared is itself, is the radicand. This is like doing rad 3 times rad 3, and I get 3. Same idea. Square the other side, and you get 100. So the square root sign disappears because this is just like a radical times itself. It's the same thing you were doing on last Thursday when you're simplifying or dividing radicals and you try to rationalize the denominator. I do know on your paper you also have some questions up here about inverse operation. Inverse, of course, means opposites. And inverse of addition is subtraction, inverse of multiplication is division, and the inverse of taking a square root is squaring something. So this new thing in solving equation is you square both sides, but you've never really done that to solve an equation. And from there it's easy. That's a linear equation to solve. You'd subtract 1 from both sides, you'd divide by 3, and you get 33. And then you'd want to plug that back in and just double check that it works. 33 times 3 is 99. 99 plus 1 is 100. I'm missing my square root, but the square root of 100 is 10. 10 minus 6 is 4. It actually works, and we're happy. Oh, there's my square root sign. It's come back. So, second set of problems, and this is really just we're going to plug and chug and drill and kill through here. Same idea. You want to try to isolate the radical symbol. So you want to try to get this radical by itself, moving the 7 over. So you'd probably subtract 7 on both sides. And because that's wrong, I'm going to pause it, and I'm going to go to part 2 here for a minute. So I've talked for a minute. I'm going to fix that, and because I can't have more than one mistake on here, because you guys are going to give me a ton of crap when I come back here, and I just can't deal with all that, troubling students. So I'll be back here, part 2 in a minute.